In this video, we are going to compare the Code Interpreter with the Noteable plugin, and we are going to find out who is better in handling the prompts, as well as who is going to perform better in the data analysis. I'm going to compare them side by side with the same prompts on the same dataset. The dataset we are going to be using in this comparison test is going to be AI index dataset. This one includes 62 different countries and how well they scored in the AI index. We then have 7 different variables: talent, infrastructure, operating environment, research, development, government strategy, and commercial. And all these variables are contributing to the overall total score of the AI index for that specific country. All these variables are from 0 to 100, 100 being the highest score. Talent represents the workforce in the field of artificial intelligence in this specific country. Infrastructure shows you the infrastructure in the specific country for the development of new AI technologies. So for example, this can include access to the internet. Operating environment is about the regulation in the specific country, as well as public opinions. Then we have research. Research shows you how much the AI is researched in that specific country. This can include the number of researchers in this field, as well as the number of publications in journals. Then we have development. Development shows you the platforms necessary for artificial intelligence, as well as the algorithms and their access. Then we have government strategy, which shows you the government commitment of that specific country to the artificial intelligence. And lastly, we have commercial. Commercial is representing the business environment in that specific country. So this can include startups and other business initiatives in the field of artificial intelligence. Then we have the total score, which sums up all these variables together in one score ranging from 0 to 100. We have a region of that specific country, so this one represents the continent. And then we have cluster. Cluster represents whether the country is a power player, rising star, or just a country that is currently waking up and trying to adapt the artificial intelligence. We then have income group, and then we have political regime, such as liberal democracy, closed autocracy, and more. All right, so right now we can start comparing. The same dataset is going to be uploaded to the Noteable app, as well as used and uploaded to the Code Interpreter. So the first thing I did was that for the Noteable plugin, I went on the app notable.io. I created my project named ChatGPT test, and I hit the upload button. And as you can see, I have uploaded this AI index dataset in the CSV format. I then have the dataset available inside Noteable, and I'm going to click on 3 dots, copy path, because I'm going to use this path in my first prompt so the Noteable plugin can easily access this dataset. All right, so we are right now going to start with the Noteable plugin. As you can see, I have the Noteable plugin enabled in this chat. I'm going to use the same prompts for Noteable plugin as well as for the Code Interpreter. We are going to start with the easiest prompts first, and as we go, we are going to make them harder all the way to more advanced techniques such as machine learning. So make sure to stick until the end of this video. All right, so our first prompt is perform a quick exploratory data analysis, calculating basic statistics. The path of the CSV file in the project is, and here's where I copied this path so the Noteable plugin can easily access this dataset. All right, I'm going to send this over and see what the plugin is going to do. All right, so as you can see, the plugin has been used multiple times. It took some time, but it was firstly accessing the dataset and then retrieving the data. And the dataset has been successfully loaded. Here is the first few rows, and then we get a quick description of all the columns in this dataset. The Noteable plugin is then being used once again, and it's starting to calculate the basic statistics for the numerical columns. And just like that, we got a very nice table over here that sums up all the statistics for the numerical columns. So you can see we have count, mean, standard deviation, mean, and as you can see, it performed it on all numerical columns correctly because it can't do this for the columns that include text. And then we get a summary over here. This gives us a good understanding of the distribution of values in each column. For example, we can see that the mean average score for talent across all countries is approximately 16.8, while the maximum score is 100. Standard deviation tells us how spread out the values are from the mean. A higher standard deviation indicates a wider range of values. All right, so right now we are going to copy and paste the same prompt inside the Code Interpreter. As you can see, I have the Code Interpreter enabled in this chat, and here I'm just going to upload a file, the same file that you have seen at the start of this video. I'm going to send this over. It has finished pretty fast. The dataset contains information about different countries with several columns indicating various metrics related to AI. We get the name of the columns and then the description of each of the column as well. Now let's calculate the basic statistics for the numerical columns and explore the categorical ones. This time we got mean, median, and range for each column that includes the numerical number. And we did not get it in the form of table, rather it printed out the name of the column and then it gave us the numbers. And actually it also had a look at the categorical columns. There are 62 unique countries in the dataset, which is correct. The dataset includes 5 unique regions, with Europe being the most frequent. There are 5 unique clusters, with the waking up cluster being the most frequent. There are 3 unique income groups, with high being the most frequent. And lastly, there are 4 unique political regimes, with liberal democracy being the most frequent. Alright, so if I should summarize this task, I liked the fact that the Noteable plugin actually put it inside a table. So I can actually take this table and copy it and paste it in Excel if I want to. But here, what I didn't like is that it didn't have a look at the categorical values as well. Whereas the Code Interpreter actually did the same stuff. The only thing is that it did not put this one in a table format, which in this case, I don't mind, to be honest. But then it also described the categorical columns for us as well. So this is what I liked about the Code Interpreter more. The other thing I must say is that the Noteable plugin was taking way longer time than the Code Interpreter, mostly because it had to be used more times. So overall, I'm giving the Noteable plugin 7 out of 10 for this task. And the Code Interpreter is receiving 9 out of 10. Alright, so my next prompt includes filtering. So I'm writing down which country has the highest research score. I'm going to send this over. The Noteable plugin is being used. And we got actually a very straightforward answer. The country with the highest research score is the United States of America. I'm going to write this prompt down inside our Code Interpreter and I'm going to send this over. The Code Interpreter has been used. And we got a very straightforward answer once again. The country with the highest research score is the United States of America. As you see, the Code Interpreter as well as the Noteable plugin did not have any problems with filtering and sorting. Once again, I'm going to say that the Noteable plugin was a little bit slower than the Code Interpreter, but it was just a difference of a few seconds. So overall, I'm giving 10 out of 10 to the Noteable plugin and 10 out of 10 to the Code Interpreter. Alright, so in my next prompt, I'm going to have a look at how they can handle aggregation and grouping of the data. So my prompt is, what is the average development score for each income group? I'm also writing down to visualize these results. And I'm going to send this over to the Noteable plugin. Alright, so we got the results in the form of table, as well as it visualized it with a bar chart. And as you can see, in the high income group, we have higher development score. In the lower income group, we have the lowest. So this makes sense. And then the results have been visualized with a bar chart. Here I'm looking at the X and Y axis, as well as the title of the chart. And it seems correct. We have income group on the X axis, then we have the average development score on the Y axis. And then we also have a title of this chart, which is the average development score for each income group. All right, so I'm copying and pasting the exact same prompt into the Code Interpreter and I'm going to send this over. All right, and so we got the results. We have firstly a chart that is showing us the average development score by income group. We have the x-axis, which is the income group, and then y-axis is the average development score. And what I like about this is that it also included the lines so we can easily see the values. And then we get the results under it as well. The average development score for each income group is as follows. High is 17.3, lower middle, upper middle. If we compare the results, they are exactly the same. All right, so in this task, I think both of them did very well. I don't have any negatives for any of them. Maybe what I liked more for the Code Interpreter is that I also got the lines so I can easily read the values. Whereas what I liked about the Noteable plugin is that I got a table for the summary. Overall, I'm giving 9 out of 10 to the Noteable plugin and 9 out of 10 to the Code Interpreter. All right, so my next prompt is testing only the visualization of the data. So I'm writing down, create a bar chart of the total score for the top 15 countries. I'm going to send this over to the Noteable plugin. And what I'm looking for is to get a visual as well as clear description of what is happening on the chart. All right, and we got the results. Here's a bar chart of the total score for the top 15 countries. We got a title, total score for the top 15 countries. And then on the y-axis, we have the countries. And then the total score is represented on the x-axis. Let's put the same prompt in the Code Interpreter. and we got the results. And again, I must say that it was a little bit faster. We got a very similar chart to the Noteable plugin, but the formatting again looks a little bit nicer. On the x-axis, total score, y-axis country, we have total score of the top 15 countries as a title. And then we also get a small description. Here's a bar chart of the total score for the top 15 countries. It shows that the United States of America has the highest total score, followed by China, the United Kingdom, Canada, and Israel. This is what I liked about the Code Interpreter more. Alright, so in this case, the Noteable plugin gets 8 points, whereas the Code Interpreter gets 10 out of 10. My next prompt is about conditional operations. So I'm writing down how many countries have a total score above 50 and belong to the high income group. I'm going to send this. And again, as we go, we get a little bit more advanced in terms of the prompts. Alright, and we got a straightforward answer. There is one country that has a total score above 50 and belongs to the high income group. I'm going to paste the same one to the Code Interpreter and send this over. And we got a straightforward answer once again. There is only one country that has a total score above 50 and belongs to the high income group. So in this case, both of them answered my prompt very easily. I didn't get the exact name of the country, but that was not included in my prompt. So I have to give 10 out of 10 to the Noteable plugin and 10 out of 10 to the Code Interpreter. Alright, so my next prompt is more about statistical analysis. I'm writing down, is there a correlation between talent score and commercial score? The Noteable plugin has been used and we got a straightforward answer. Yes, there is a strong positive correlation between talent score and commercial score. The correlation coefficient is approximately 0.795. This suggests that countries with higher talent scores tend to also have higher commercial scores. And this really makes sense. If you have a very good talent and workforce in the field of artificial intelligence in your country, you are most likely also going to have better commercial score in terms of the number of startups and businesses in the artificial intelligence industry. I'm pasting the same prompt inside the Code Interpreter and I'm going to send this over. And we got a straightforward answer. Yes, there is a strong positive correlation of approximately 0.795 between the talent score and the commercial score. This suggests that the countries with higher talent scores tend to have higher commercial scores as well. In this case, I must give the Noteable plugin 10 out of 10 and Code Interpreter receives 10 out of 10 as well. Alright, so right now, because we talked about the correlation, I want to produce a more advanced visual here. So I'm writing down visualize correlations of talent, infrastructure, operating environment, research, development, government strategy, and commercial scores in the dataset. And here I'm not specifying what type of chart I want to produce. I'm leaving it up to the Noteable plugin, so we're going to see what happens. I'm going to send this over. So hopefully it's going to choose the most appropriate chart for this visual. Alright, so we got the results. Here's the correlation matrix of the various scores in the dataset. We got the correlation matrix over here, and we got all the variables on the y-axis as well as on the x-axis. And then we have the values directly inside this matrix. We also have a title, correlation metrics of various scores, and we also get a description under it. The heat map shows the correlation coefficients between different pairs of variables. A correlation coefficient close to 1 indicates a strong positive correlation, while a coefficient close to -1 indicates a strong negative correlation. Coefficients close to 0 indicate little to no linear correlation. From the heat map, we can see that most of the scores are positively correlated with each other. For example, talent and commercial have a strong positive correlation as found earlier. So let's have a look at the talent and commercial. As we can see, the number is 0.8, which represents the 0.759 that we calculated before. Alright, so this time I'm putting the same prompt inside the Code Interpreter and we got the results. So here we have the visual once again. We have a title, correlation metrics of AI metrics. On the y-axis, we have all the variables as we have on the x-axis. And then we also get a description over here. From the heat map, we can see that there is a strong positive correlation indicated by the darker red color between several pairs of these metrics. For example, talent and commercial have a strong positive correlation as we previously calculated. It's important to remember that correlation does not imply causation. While these metrics may move together, it does not necessarily mean that one is causing the other. And this is one of the most important things in the correlation metrics. So I'm really pleased that the Code Interpreter actually mentioned this. The other difference is that the Code Interpreter used just one color palette, I would say. In this case, it was the red one. And then the darker the color, the stronger the correlation. Whereas here it used red one all the way down to blue one. I mean, in this case, it's really a preference of what you like more, but this is just my personal opinion. I must say that looking at this visual over here, it's a little bit more confusing to see more colors, where I know that I only have one color, and the darker the color, the stronger the correlation. And because we also got this line over here, I'm giving the Noteable plugin 7 out of 10, and Code Interpreter receives 10 out of 10. Alright, so my next prompt is the most advanced so far, and it's about machine learning and predicting values. So here I'm being very general, and I'm trying to be general on purpose to let the Noteable plugin decide what it's going to do. I'm writing down build a predictive model to estimate a country's total score based on other factors. As you can see, I'm not writing down what kind of model it should use, and I'm also not specifying which factors it should include. I'm going to send this over. Alright, so we got an answer over here. To build a predictive model, we first need to decide which features columns we want to use to predict the total score. For this example, let's use talent, infrastructure, operating, and basically all the variables that are important for the total score. Given that we are predicting a continuous variable total score, let's use a simple linear regression model for this example. We also got a step-by-step how the Noteable plugin is going to do this. It's going to split the data into training and testing set, then train the model, and then evaluate the model. So it's firstly starting to splitting the data. The model has been trained and evaluated. It firstly calculated the mean squared error, and then we also got an R squared, which is approximately 0.99 or 100%. This means that it's a very good model, and it makes sense because all the variables are actually used to calculate the total score. Then it explains the mean squared error and says that the closer to 0, the better. You can see that it's very close to 0, it's almost 0, so that's good. And then also it explains the R squared. The R squared score, also known as the coefficient of determination, is a statistical measure that represents the proportion of the variance for a dependent variable that's explained by an independent variable or variables in a regression model. R squared score of 1 indicates that the response variable can predict without any error using the model. And then it also writes the summary and explanation in this specific model. So the R squared score is very close to 1, which indicates that our model explains almost all of the variability in the total score data. This suggests that our model is a good fit for the data. However, it's worth noting that this is a simple model, and there may be other factors not included in our model that could influence country's total score. Also, the model might be overfitting the data, meaning it might not generalize well to new data. Alright, so I'm copying and pasting the same prompt into the Code Interpreter, and I'm going to send this over. We can build a predictive model for this task. Let's use simple linear regression model for this purpose. Firstly, we need to pre-process the data. We will one-hot encode the categorical variables and then split the data into training and test sets. Alright, so in this case, you can see that it's not using just the numerical data as the Noteable plugin, but it's also trying to encode the categorical data, which is the textual data. And then it actually writes the step-by-step how it's going to do it. Alright, so firstly, it's splitting the dataset, and it calculated the root mean squared error, which was approximately 0.0038. And then it also calculated the R squared once again, which is approximately 1 in this case. These results indicate that the model has an excellent fit to the data, almost perfectly predicting the total score based on the input features. This is likely because the total score is derived feature, probably an aggregate or weighted sum of the other scores. In the real world situations, predictive models rarely achieve this level of accuracy. If you want to predict total score based on the non-derived features, like income group, region, the model's performance may not be as high. And then as a second step, the Code Interpreter actually tried to use one-hot encoding for the variables that were not numerical, so then it can encode them and include them in our model as well. So this include the region, cluster, income group, and political regime. And as you know, you only can include columns that are numerical, but in this case, Code Interpreter is actually encoding them And in this method, it creates a new binary column for each category in the original column. It then writes down the steps. And once again, we got the root mean squared error. And then we also get the R squared, which is still approximately 1. This indicates that the model, even after including additional categorical variables, is still able to almost perfectly predict the total score. However, a slightly higher root mean squared error compared to the previous model suggests that the categorical variables introduced a small amount of error in the model's predictions. This exercise demonstrates how you can build and evaluate a simple predictive model using both numerical and categorical variables. In a real-world setting, you would typically perform additional steps such as feature engineering, model selection, and hyperparameter tuning to optimize your model's performance. Alright, so in this case, I must say that the code interpreter was performing a little bit better. It dived more in depth, and it also tried to use the categorical variables and not just the numerical variables as the Noteable plugin. We got very similar results, but in the code interpreter, I like the fact that it mentioned a lot more in terms of what is it doing, as well as what you can do in the future. In this case, I must give 8 out of 10 to Noteable plugin and 10 out of 10 to the code interpreter. Alright, so additionally, what I have to include in this video is the fact that in the Noteable plugin, you can actually go inside the notebook that has been created for you. If I click on this one, I'm redirected to the notebook where all my code is stored with all the visuals as well. You can see what is importing from the Python library and how the code is executed. If I go back to the code interpreter, I can only see the code if I'm clicking on this arrow over here. So if I click on this one, I can see the exact code that has been used to visualize these results and what libraries had to be imported as well. So in this case, I can access the code in Noteable plugin as well as in the code interpreter. But here, what I like about the Noteable plugin is that the code is stored in the notebook with all the visuals as well. So it's very easy to go back to it whenever I want to. Whereas for the code interpreter, I would need to click on the arrow and then copy this code, for example, inside my Visual Studio and execute the code to visualize the results. So in this category of accessing the code and storing the code as well, I must give 10 out of 10 to the Noteable plugin and 7 out of 10 to the code interpreter. Alright, so the overall score that the Noteable plugin has received is 79 points out of 90 possible. And then the code interpreter actually has received 85 points out of 90, which makes the code interpreter a winner with a 94.44% score, where the Noteable plugin has a score of 87.77%. Alright, if you enjoyed this video or if you learned anything new, please give this video a thumbs up. If you're interested in data analysis, tech, and AI, then definitely subscribe down below because I post every single week. Thank you so much and have a great day.